Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the Deep Programming Language series. In this lesson, we're going to continue our discussion about structs. So I want to go ahead and talk about and do a little bit of a recap of what we did in the last lesson, and then I'll continue to talk about some of the important semantic differences with structs versus other programming languages that you might have used. So with that said, let's go ahead and do a brief recap of structs and why they're important and a useful feature in the Deep Programming language. Now, again, if you're coming from other programming languages, you've seen structs before, but structs, again, are a way for us to create our own type. We can have fields, whether those are primitive fields or other structs themselves, and member functions that are part of this structure so that we can call on specific instances. And I'll go ahead and show an example here, a specific instance of Mike here, that is a student, with its own set of data here, this particular object, Mike here. And then we can call print on this specific instance of Mike, which will run the print function here for that specific instance on its particular data. So again, structs are a way for us to bind together the sort of data and the actions in a sort of object-oriented way and allow us to achieve some useful work and encapsulate the data, again, with a particular instance of an object. Okay, so that's a little bit about structs, what we learned last time, and probably a little bit of a review if you're coming to D from another programming language. But what I want to go ahead and say here is there's something important about this struct here. And this is one of the important things to keep in mind with structs in the D programming language. So let me go ahead and bring us to our favorite website, dlang.org, and we'll go ahead to the language reference, and I'm going to go to structs and union. And I'm going to go ahead and just scroll down here a little bit just so you can see how structs operate. And the first important distinguishment that I want you to know about structs is that for local variables, a struct instance is allocated on the stack by default. So that means a struct is a value type. That means that it's going to be allocated on the stack, and then when it goes out of scope, it will be destroyed. So you don't have to do any fancy memory management with it. And that's going to be different than classes, which we'll learn about later in this series. So let me just go ahead and take a few notes here. So stacks or structs are stack allocated by default. Let me make sure I spell everything right. There we are, by default. Okay, so that's the first point to keep in mind with structs that are going to be a little bit different than other languages. And if you're coming from Java or C# or other programming languages, you might think of structs again just as value types versus reference types, which we've discussed earlier in the series. The other thing that I'll note here is that we do not allow inheritance with structs. So you can't code to an interface, which we'll show interface again later in this series, and you can't inherit or build one structure from other ones. So that means that you're making a design decision early on when you're using a struct. And that's a good thing, in my opinion, and a great feature of the deep programming language that makes this distinguishment between structs and classes. It makes sense of when to use those different keywords. So with that said, let's go ahead and just look at some different things that we can do with structs. Now you'll observe here that we can heap allocate a struct, for instance, if we need its lifetime, that is to hold on to that object for a longer time, or maybe make a really large allocation of a lot of different structs. So that still is available, but let's go ahead and just see the difference here. So here I've got Mike, and a way to sort of see how this works is let's just code a function called pass in student. That's going to be a demonstration of struct being stack allocated by default. Okay, I'm going to go ahead and clear away some of this other stuff that we did in the previous lesson. I'll leave the introspection here because I think it's neat here. But let's go ahead, and what we'll do here is I'll go ahead and set up Mike here with an ID and an age here. And I'll call this pass in student function here. And let's just start by passing in Mike. Okay, so this is going to be a regular student S here, whoever that student is. And let's just set the ID equal to 000 and the age equal to 0 as well. Okay, so in following this program here, I've set my ID and age for this Mike that's stack allocated within the scope of main here. And when I call this function, what I'm really going to be doing is passing in a copy of this student into this function that's going to get modified. So when I print Mike, I should still see the original values here. So let's go ahead and run this. And in fact, we do get ID 1234 and age of 99. And then the rest of this code, which let's just actually comment this out so you don't get confused here. The introspection here, that's just printing out the members, which is a cool thing you can do. So let me go ahead and run that. There we are. So age 1234 99. So again, we're just passing in or making a copy of this object that we're actually modifying. Now let's actually change things up just a little bit here with some things that we've learned in D before. If we do want to modify this actual structure, right, we have the ref keyword, and we've looked at this in functions for how we execute things. So now in this case, when I run it, because I'm saying ref, which means, yeah, actually refer, pass by reference, Mike here, into this function and actually modify this stack allocated object, which is in scope here, into this function and update it. Okay, so that's the idea there. So that will actually update anything, even if it's stack or heap allocated. Now, the third thing that I can do here is I can pass in a pointer here to s, which we've learned about pointers. And if I run this, well, first, let's see, it's going to say, well, it's not callable. I need to pass in a pointer here, which means I need to pass in the address of Mike here, right? Because pointers, student pointer here, and just like we can have pointers to regular variables, we can have pointers to structs. I need to pass in the address of Mike here. And this will again have the same effect as ref here. Okay, I'm passing in a pointer here. Now again, another little difference between C and C++. For those of you folks who have used that language, you don't need to dereference and do an arrow here or any, of this sort of stuff here. Let's see if we even do it here. Let's see. Air can only, star a pointer, not an int here. Okay, so we don't need to do that when we're accessing the individual fields of a struct. Okay, even if we have a pointer. Okay, so that's just kind of a nice thing actually in the D programming language. Okay, so now let me go back here, undo these changes here, and again, just have a regular stack allocated student here, passed in here. Again, just making a copy. Let's go ahead and run that just so they can see, again, no modifications here. But what if we do heap allocate Mike here? What if I do say new student? Okay. And again, I go ahead and run it. And let's see here. Error cannot implicitly convert new student 00 of type student star to student. Okay. So, well, what is happening when I do new? I'm allocating memory. So that means I need to store it somewhere. Okay. So I can do student star here. Okay. Because it's a pointer here. And then now I'm getting an error about, well, how I'm passing in this student. Okay, so let's actually pass this in as student with a star. And now we'll see that since this is something that's heap allocated, it's now a reference. So when I pass in Mike here, I'm referring to it just like we saw previously with the pointer example, and I'm actually modifying the specific instance of Mike here, right? This is located in a heap memory. This is the actual Mike that I am passing in. Okay, so let me just add in comments. Here is a heap allocated Mike here. Okay, just so we see here. Now, just to make this crystal clear, let me go ahead and back up here, and I'll just do it as a separate example. Okay, so let me go ahead and pass in demonstration of a struct that will be modified. Okay, and let's go ahead and make this a pointer. Pass in student by pointer or reference. Okay, just so you can see that here. Here is our student Mike. Let's kind of group these together just so we can see this example. Pass in the student. I'll print Mike here. And then let's create another student. Heap Mike equals new heap allocated version of Mike. And again, the ID is equal to, 1, 2. Let's just make this different here. 5, 6, 7, 8. Mike, heap Mike for both of these. Heap Mike equals 100. And heap Mike ID 5, 6, 7, 8. pass in student by pointer or reference. Again, this is our heap mic. And then let's do heap mic dot print here. Okay. And now let's go ahead and run it. Oops, let's go ahead and see. This needs to be a new student here. Okay, there we are. And it says, I just again forgot going through this a little bit too fast. The age here. Now we are good to go here. Okay. So now again, you can see since I am passing in for the second example with heap mic, and even though I've set up these values, when I'm passing it in, I am modifying it, right? So that's why it's getting zeroed out here, just like we saw here. Okay, so you can see the two different versions here, whether we are stack or heap allocating this struct here. So with structs, again, just to recap this, by default, they are stack allocated. You can use them, but you can heap allocate them if you do want control. If this is something that might need to live beyond scope here. Okay, so that's it for this lesson. And that's the big takeaways here about stacks being allocated, or structs, excuse me, being allocated on the stack by default. And they don't allow for inheritance, which we're going to see in classes. You won't see a lesson on inheritance or some of these other object-oriented things that you've learned with structs. It's just not possible, which is again important because it's just a design decision about how you're using these different concepts. Now, luckily, it's pretty easy to switch between struct and classes in the D language. As you saw, you don't need to worry about changing the dots to arrows or these different types of things that you might have seen in other programming languages if you're coming here from C++. So that's really nice in my mind. Now, again, as always, these lessons are found. You can visit the courses.msha.io page and follow along and track your progress on the D programming language if you want. That's free, just to go ahead and track that there. And as always, folks, let me know in the comments if you have any questions about structs. We're going to keep looking at them because there's a lot of interesting things that we can do. And again, they're a way to compose and build up larger and more interesting programs with structures. All right, folks, with that said, thank you for your time and attention, and I'll see you in the next one.